Hi and welcome to this video on measuring the distribution of organisms, which is one of the required practicals. In the first example, I will talk through how to measure the population size of a common species in a habitat, such as a dandelion flower. For this, you will need a piece of equipment called a quadrat, which is a small grid that you can throw onto the ground and count whatever ends up inside it that is of interest. Sometimes there is overlap of the species in question with the edges of the grid, so to compensate for this, you should only count those that overlap in two edges of the square, such as the left and the bottom of the quadrat, and ignore those that overlap on the other two edges. In this case here, I would count 4 yellow dandelion flowers. I would count this one that overlaps as it is on the left and ignore this flower that overlaps on the right. This procedure should be repeated for 10 quadrats or any suitable number of repeats. Each time, to eliminate bias, the quadrat should be thrown randomly or blindly, such as behind your back. Or even better, a random number generator could be used to get coordinates. You then would need to use a tape measure positioned like graph axes along two sides of your chosen area to sample in, which could be a school field. Let's say the first two random numbers generated were 10 and 15. A person stood at 10 metres along a tape measure, and a second person stood at 15 metres along the other tape measure, would walk from their relative positions onto the field, and where they meet, they would place a quadrat onto the ground, placing the bottom left-hand corner down wherever X had marked the spot. You would then do the counting inside the quadrat as normal. Once you've done your 10 repeat counts in your 10 randomly placed quadrats, you add all the dandelions counted together and divide by 10 to work out the average number of dandelions per quadrat. So if the field measures 20 metres by 60 metres, its area would be 1,200 metres squared. The quadrats are 1 metre squared quadrats, so therefore we would be able to fit 1,200 of these quadrats onto the field. Rather than counting all the dandelions in every single one of those quadrats, we could do a 10 quadrat sample and use that to estimate. So if in those 10 quadrats that we used to sample, we worked out that there was an average of 4 flowers per quadrat. So we will times this by the maximum number of quadrats we can fit onto the field, which is 1,200, and that gives us an estimate of 4,800 dandelion flowers on the field. In the second example, I will look at how to measure the distribution of organisms and how they change. This would always be linked to an abiotic factor like light intensity, pH, salinity, etc. To measure this, you will need a transect, which is basically a tape measure, and this is placed across the habitat. Quadrats are then placed at regular intervals along this transect, rather than being randomly placed, as if we were just estimating the population size. In this image, the transect is in between two posts. Regular intervals are marked along this transect, and at regular intervals, such as at every metre or every 5 or 10 metres, a quadrat is placed onto the ground. Whatever is in it is counted. To ensure the distribution map of the species is reliable, a repeat transect would be done. Here the transect must be placed parallel to the previous one. And in this illustration here, you can see that there is a difference in the type of plants that are distributed as you go from 0 to 30 metres along the transect, with quite a lot of lavender style plants at the back of this habitat rather than at the front. In a typical exam question, you may have to write an extensive answer to a question like, describe how to measure the distribution of plants from bank to bank across the river using a 1 times 1 metre quadrat and a 30 metre tape measure. This could be worth something like 6 marks. I would recommend you pause the video at this point, attempt to answer the question yourself, and then resume play. Otherwise, let's continue. So you first place a 30 metre transect across the river from bank to riverbank. Have regular intervals along that transect and place a quadrat at the surface of the water at those regular intervals. Count the number of each species of plant in those quadrats. And here it looks like you have 4 different species on each bank. Let's call them species A, B, C and D. Number 4, run additional parallel transects upstream and repeat steps 1 to 3. Number 5, map the distribution of each species as in this diagram here. And you can see that there is overlap sometimes, and where there is overlap of species, there will be competition for resources such as light, minerals, water, and space. You can also deduce from this type of practical that the reason why species are distributed in this way is because the habitat conditions are different. So species A are both higher up on the riverbank. They are clearly more tolerant of dry conditions and more adapted to them, while species C and D are better adapted to be more aquatic and more permanently submerged in water. So hopefully you've enjoyed this video. Do make sure that you can distinguish between when to just use a quadrat on its own and when to use it in conjunction with a transect. On its own, a quadrat is used to estimate the population size of a particular species, and the quadrat must be placed randomly. When used with a transect, you are looking at how species distribution changes from one point to another, and here the quadrat needs to be placed at regular intervals. In both cases, you must mention that you need to count whatever is inside the quadrat and specify that when you're repeating an estimate of population, you throw the quadrat more and more times. When you are repeating a distribution study, you need to set up a transect in parallel. Thank you very much for watching, and do check in again soon.